So from a prediction point of view, the other important thing that would be required or business would be in the need of is to know the demand. For example, if hub A dispatched 120 today, yesterday, and 140 today, what will it dispatch tomorrow? So these kind of questions we might get from the operation team. Why? Because to align manpower and vehicle allocation, right? To pre-meet cutoff congestion and to feed forecast loads into route scheduling and capacity planning systems. Let's take let's take a look at the core concept here. Unit of forecasting should be on the level of source center and that date. The target variable is going to be the trip count, and time granularity is going to be the daily or hourly for dynamic routing. But we are actually calculating daily here. Prediction is going to be next 1 to 7 days, and the key driver we are going to have is the weekday hours, historical load pattern, seasonality, and special event. So for this, in the data preparation, there's not much we are doing because this is time series analysis and it auto correlates. So the we are only focusing most of our attention on the trip count, but we got to make sure that all the time dependent feature are in a daytime format, and trip date we have to put it into date as well as hour format, trip hour. And the daily load, we discuss the granularity of the data, and the daily load should be grouped by on source center level, and we want to see the trip date and trip count. So for each source center you can see that for a given date this is the trip count. Let's have a look at what features we are going to engineer. We are going to do a date feature engineering. We are going to calculate some lag features and rolling averages. So for date features, we are simply making use of trip date. Day of the week, we are making sure that we are getting into day of the week format from the trip date, month also from the trip date. Lag feature, lag one, we are shifting it by one. Basically, we are subtracting the, I mean, we are shifting the data by 1 day and bringing it down to the current. So that will be the lag one. And lag 7 is doing the same operation and basically shifting it down to the last 7 days and bringing it to the current value. And uh, rolling averages, we are doing a 3 day rolling averages. So how is it calculated? It is by taking average of last three and putting it as the current value. Same for rolling 7, taking average of last 7 and putting it in as the current value. And growth, we are calculating the demand growth, which is calculated by taking a trip count minus rolling what was the rolling 3 day average, and taking and dividing it by rolling 3 day average. So if it is increasing, we would assume that it is going to increase in a 3 day window, or if it is decreasing, we would assume, or that's what we can infer, that the demand is going to decrease. Let's also, before jumping to model training, let's also look at how the data is actually looking like after these transformation. So you see day of the week is added, month is added, lag 1, lag 2, rolling 3, rolling 7, and the growth percentage. And training this again using XGBoost as our model, and performing the same operations of selecting the features, putting into X and Y bucket. Y is the one which is going to be the dependent variable, is going to be the trip count. Taking that split of 0.15 or 85% of the data would be test, and rest 15% will be in the train. And the model we are using XGBoost with all this hyperparameter. We have fitted the model, and the accuracy, just like before, here also we are seeing a very high accuracy. And again, the forecast. Uh, s- let's have a look at how the forecast would look like for a 100-day window. So you can see the predictor is mapping very closely to the actual, and from this we can also infer that there is a uh, on after 80 days there is sudden demand. So looking at this data, people from the operations team, they can proactively take measure to fulfill these demands. Okay, we can also use advanced model profit models for better accuracy, but at the same time, if we have very high accuracy, we should be focusing more on drawing business insights rather than proving, marginally the frequency, as it is already quite high. So this was about demand forecasting. Next, we have is the delay probability classification.